introduce briefly the title of this session, which is Innovative Methods for Cultural Heritage Digitization and Energy Simulation and Monitoring. Many of the authors are online. Actually, I think all of them are already online. So if you all agree, I would simply introduce the first speaker of this session, which is Franca Fauci, which is already online and with the camera switched on. Yeah. And she will present, I think, together with her colleague Alessandro Monti, the first work of this session, which is entitled CDITA, Collaborative Digitization of Natural and Cultural Heritage. Please, Franca, feel free to begin whenever you're ready. Just be warned that since some of the authors have very strict timing, we need to be very precise and strict in respecting the time span of 15 minutes plus 5 for questions.
Okay.
Okay.
I'll try to do my best. Okay.
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 Let's begin when you want and share your screen.
I think I have some problems.
Okay, it's working. It's working
it's
now.
Working?
Yeah.
I'm so sorry, but the connection is not so easy. Okay.
Okay, perfect.
Okay,
we can see.
Okay.
We can see correctly.
So, first of all, I'm particularly pleased to be here today in a conference focusing on central issues such as the future of heritage science and technologies, which is the core issue of our European CDITA project. But let me start by introducing you to the foundation for which I work, the Foundation for Research and Innovation, which is currently promoted by the University of Florence, the Metropolitan City of Florence, and Foundation Cassa di Risparmio di Firenze, a foundation with banking origins. The Foundation for Research and Innovation aims at technology transfer and higher education. Our mission is to facilitate and stimulate connections and knowledge transfer for a diffusion of an innovation culture at all levels. The Foundation is a partner of a 5-year project, CDITA, Collaborative Digitization of Natural and Cultural Heritage, a European project within the framework of Interreg Europe and the regional cooperation program aiming at enhancing regional development policies through exchanges of experiences and good practices. The main objective of CDITA is to improve the implementation of policies on digitization for natural and cultural heritage through the identification of best practices and the stipulation of 8 action plans, one for each member state partner involved in the project. As you can see here, the partnership is very well balanced, both in terms of regions and competencies. The lead partner is the Euro-Region Pleven-Old from Bulgaria. We also have Argita County Council from Romania, the University of Patras from Greece, the Estonian War Museum from Estonia, the Regional Development Agency of Governi from Slovenia, the Foundation St. Mary the Royal of Historical Heritage, and the Association of Municipalities della Ribera Alta from Spain, and finally here we are, Fondazione della Ricerca from Italy. During the project, of course, we have carried out a lot of activities. The project has already concluded its first 3-year phase, during which we have carried out local stakeholder meetings focusing on the digitization of natural and cultural heritage with involvement of representatives operating the sector of culture, such as local and regional authorities, museums, galleries, libraries, archives, and technology companies, and so on. We have also organized inter-regional work meetings and thematic seminars. in order to identify and exchange good practices with our valuable examples for their innovative approach that can ensure conservation, promotion, and development of natural, cultural, and historical heritage, enhancing cross-border cooperation and capacity building in the sector of digitized cultural heritage. Another important activity, the drawing up of action plans. Since during this period, each involved partner has hardly worked to lay the basic foundation for his own action plan and get designing by the local responsible body. As far as we are concerned, it is worth mentioning here that our action plan set up with the support of the Department for Culture and Research of the Tuscany region has already been signed. Moreover, the Department for Culture and Research of the Tuscany region has also expressed and confirmed to support our project for the ongoing phase, the phase 2. In an endorsement letter that acknowledges the importance of the action plan for the whole territory. Our action plan consists of 4 main actions having the purpose of enhancing digitization of natural and cultural heritage in Tuscany, concerns the integration of project findings into other strategic plans, such as the Tuscany Region Plan, the action plan, the operative plan of the National Technology Cluster of the Smart Communities, and the strategic plan of the Metropolitan City of Florence. And such actions are strongly aimed at exploiting the existing Tuscan best practices presented to the CDATA partners during the international thematic seminars, and all the other best practices learned during those events as well. Most of the best practices, of the selected best practices, offer huge opportunities for increasing industrial competitiveness, growth, and jobs, thanks to the combination of digital technologies such as big data, Internet of Things, high-performance computing, with other advanced technologies and service innovation. As a representative of the Foundation for Research and Innovation of the University of Florence, let me say that all the free team is really proud of the CDATA outputs. As a matter of fact, Italian good practices have been a source of inspiration for several partners. Besides the influence on the Tuscan region, they have sparked policy improvements in Greece and our pilot action carried out in a collaboration with our Estonian partner. And indeed, 2 good practices attracted the interest of one of our partners, Patras University, because of their high technology level, Galileo Museum app, and Uffizi virtual experience, Uffizi Touch, by the Italian company Centrica. Galileo Museum app is a free guide to the museum, accompanying users through the collections of scientific instruments with video, audio, and images. Uffizi virtual experience, Uffizi Touch, is a fully immersive and interactive digital exhibition dedicated to the art collection of the Uffizi Gallery. Both good practices were first discussed and analyzed on the occasion of CDATA local stakeholder meetings led by Patras University. And then they were included in the Greek action plan and presented to the Regional Council of the region of Western Greece, which took them into account in a call for projects within the framework of the Regional Operational Program as an additional action. The proposed action aimed to enhance the competitiveness of the enterprises of Western Greece operating within the context of creative industries. And what about our pilot action carried out in collaboration with the Estonian War Museum? Although Estonia is very well advanced in general ICT development and also in the digitizing natural and cultural heritage artifacts in museums and in memory institutions, institutions. So there is a clear need to introduce a wider use of 3D modeling, so to boost cooperation between museums and creative culture industries and to promote culture. For that reason, the Italian good practice digital fabrication techniques for cultural heritage by the Visual Computing Lab has been taken as a model. As a result, our action plan will contribute to achieve the aims and objectives of the policy instrument addressed, the Estonian Operational Program for Cohesion Policy Funds. Now, together with our policy responsible authority, we are focusing on keeping the project plan on track with a careful monitoring strategy based on a continuous interface between us and our stakeholders. So our main aim is to maximize the project potential impact and ensure that the new knowledge and results have a direct influence on the relevant policy framework. So we really wish that our action plan will bring a really added value to the territory and the stakeholders concerned. So our action plan, the main and key output of the CDA project phase 1, will be specifically described in its genesis and implementation from the very early stage up to the startup of phase 2 and beyond by Alessandro Monti. The floor is yours. The screen is yours.
Thank you so much, Franca. If you can, okay, I will try to share my screen and, okay, here we are. You should see it now.
Yes, we see. You can
Fantastic.
go.
Okay. Yes, thank you. So the action plan, as you can see, our project had two main souls, a technological one, which was all the best practice we gather all around Europe in order to digitize natural and cultural heritage. But the other problem was to put all this information, all these outcomes into something that could be easy to exploit, especially from public stakeholders, our action plan. So the first main idea was to design a very peculiar action plan, something that was not, let's say, a new, completely new document, but we built 4 different actions, which, as a matter of fact, were included in existing policy instruments, planning instruments, and strategic instruments. In this way, let's say that we put our tech discoveries, our best practice, and so on, into something that was already moving on. The action plan, as you can see, was designed just to describe what was the background of the idea, what was the action, players involved, the time frame, costs, and answers. The aim was aimed at delivering into the hands of public stakeholders, mainly something that could be very easy to use, very easy to implement. So not too many questions. You have everything in here. Our action plan, as Frank already said, is composed by 4 different actions. The first one was the creation of the database of best practices gathered all around Europe during the project development, and it was put inside the task.
Sorry, teacher, sorry.
Okay, going on, the database was included inside the Tuscany region platform, side by side with the tenders and the call that the Tuscany region issued in terms of digitization of cultural and natural heritage. In this way, we answered to one of the most important needs of the territory. Companies or museums or other kind of players looking for solutions, they could find the solution side by side with the funding in order to accelerate the process of preparing a good proposal and solving the problem. It goes without saying that the idea was not so original, but it was inspired by many previous great projects such as Europeana. The second action was related to including the outcomes and the results of the project inside the update of the Smart Specialization Strategy document. The update was performed by IRPET, and thanks to them, we were able to put some keywords inside it. This document, the update of the RIS3, it's very important because it's a very widespread document, which is used by many potential appliants to public funds, because when you apply to a fund coming from the Tuscany region, you have to respect the roadmaps of the RIS3 in order to be awarded with special, let's say, with some adding points. So third action, it was, once again, let's put CDETA, its results, its outcomes, inside another instrument. We changed scale. We are no more on a regional scale. We are on a metropolitan scale, specifically the strategic plan of the metropolitan city of Florence. This is a very even more widespread document because it's aimed also at the citizens, among which we find also companies, museums, and so on. In this way, by means of a very interesting scheme that, as you can see, started from vision, going to strategies, action, and pilot project, we were able to develop new projects thanks to the outcomes of CDETA on our territory. And most of all, we had the chance to widespread this in a very wide way. Finally, action number 4, the integration of CDETA results, outcomes, once again, inside a national strategic and planning instrument, which is the action plan of National Technological Cluster of Smart Communities. This is the CTN, the Smart Communities Clusters. You know, it's one among 12 that we have.
Sorry, it's not me. It's not me. It's Gabriela, Gabizinha. It's not
sorry,
me.
we are.
I listened to the lesson.
Me. Lapo, help. I don't know if I'm the only one.
Just go on. Just go on for the moment.
Okay. So just to finish, this instrument was able to bring the CDETA projects, best practice, and so on a national scale, specifically aiming at the region, especially the ones of the south part of Italy, since this instrument is by will of the two ministries, specifically aimed to that region. So I would say that this is all. I want to thank especially Diana Tastic, which was a digital strategist who provided us with some very interesting insights on how to develop such a complex action plan made by different decision strategic instruments. Okay, thank you to all of you. And I don't know, Lapo, if I was heard or not, because I...
Yes, you've been heard, but unfortunately many other people were heard too. So please stop interrupting speakers and switch off your microphones and keep them switched off. Okay? I'm referring to the people that were talking during Alessandro Monti's presentation. Okay? And please do not use this chat in the Google Meet channel for private purposes. This session is being recorded, so please use the chat only for questions, as reported into the manual that whose link has been posted in the general chat. Okay? People interrupting presentations will be removed from the meeting. Okay? Also, let's go on quickly. Are there questions for this presentation? For this interesting presentation about European project? Okay, I have a brief question, short question myself. You were talking about a sort of repository where best practices were contained and described together with applications from different partners and countries involved in the project. If I got it wrong correctly. And I would like to know, is there an attempt to extrapolate from these best practices some common factors, or they are presented just as they are described by the people who carried out the work?
Well, no, there was not an extrapolation of common factors. The idea was to have best practices coming from different regions with their specificities. So that was precisely done in order to leave this kind of specialties of the single best practice. So we know that there could be not so easy to apply just like they are this best practice to any kind of situation. But let's say that there is a little bit of space of maneuver, especially if you get in touch with whoever developed it. So no common factor by choice in order to maintain how these best practices were so peculiar, referred to the region from where they came from.
Okay, thank you for your answer. Are there any questions? Are there more questions? No. Okay. Thank you again for your presentation to Franca and Alessandro. Let's move to the following presentation, which is BIM for Built Cultural Heritage, the case of the Baptistry of San Giovanni in Florence. And as far as I know, this presentation will be delivered by Carlo Bianchini. No?
Giorgia Potestà.
Okay. In this case, Giorgia Potestà.
Yes.
Okay, the other author of the work. So please share your screen. Welcome to the session.
Thank you. Good evening, everyone.
Okay, we see your screen.
Okay.
Okay, feel free to start when you want.
Okay, so good evening, everyone. I'm Giorgia Potestà, and the research I will present today concerns the application of BIM systems to cultural heritage and focuses on the definition of an application methodology. So in this research, each BIM consists in knowledge, communication, and management of monumental building heritage. And I start with the definition of load, level of development, that precisely define the level of depth of each kind of information contained within the model. But is the level of development equivalent to graphic details? And in true, not. To me, because the level of development differs from the graphic details according to the attributes that can populate the BIM object in each design phase. So the level of development consists in the distinction between level of geometry and level of information, and graphic detail or level of detail is applying only to the geometry. So the distinction is based on the attributes. Then, once we define this distinction, we try to define different levels for the level of detail, starting from the Vitruvian triad of Firmitas, Utilitas, and Venustas. And we distinguish three different levels. There are a construction level, in which we can define the structural parts, for example, of an architectural order, the functional level in which we can define all different parts of the order, and then the decorative level, according to the definition made by Riccardo Migliari in 1991. So, starting from this, we can make a redefinition of data flow in digital process through loads, in which we have the distinction inside the level of the development in level of geometry and level of information, but we define also other levels that are thematic levels, in which we have, for example, the level of detail, the level of reliability, that is based, that define the accuracy of each model elements, and also the level of evolution that can represent each building phases of the monument. Here you can see an application on the right side of the level of detail on a column, the level of reliability.
Excuse me, Georgia, but your microphone must have some problem, and we cannot always hear you correctly. Please check the connection of the cable if you have one. I don't know. From time to time, your voice goes.
Okay. Can you hear me now?
Yes. Sometimes we can, some other we cannot.
Oh, okay. I don't know.
Okay. Okay, go on. It's
Okay.
you can deal with it.
Okay. An application of the level of reliability at the Tempio del Divo Claudio in Rome, and also an application of level of information on the Casa dei Cavalieri di Rodi, also in Rome. The methodological approach of this research is based on 4 phases that are the knowledge, so the creation of a database of information, historical information about the monument, and also the TLS survey of the Baptistry of San Giovanni, the breakdown phase in which we define all the ontological elements of the architecture, the reconstruction phase, and then the dissemination phase in which we make a validation of the HB model. So for the first phase, we start with the definition of all building phases of the baptistry, and you can see also a collection of historical plans starting from 1490 to 1830. This is the TLS survey that was conducted by the University of California, San Diego. On the right side, you can see all the scans position, and also an application of a Gpr analysis. This is an important analysis because thanks to this, we can define the thickness of the marble slabs inside the monument that are more or less 8 centimeters. The breakdown, thanks to the breakdown, we can define all the ontological elements of the facade, and also on an orthophoto we can make an individuation of hierarchical architectural elements such as openings, supports, and capitals. For the third phase, that is the reconstruction of the geometry, we can define 2 different categories that are architectural elements and decorative elements. The architectural elements are replicable inside the model, so we can use an internal modeling starting from the use of the Revit families, system families, nested loadable families, and local families. For the decorative elements, we use an external modeling starting from the mesh modeling. Here you can see the reconstruction of walls using system family. And then we can define also the internal stratigraphy of the wall, starting from the information began from the historical research. Same things for the system family of the roof. Here you can see roof modeling of the scarsella made by 2 different types of roof. All lintels and moldings are modeled by local family. On the right side, you can see a survey profile made by Paolucci in 1991. And for the columns and pilaster, and also for windows, we use a nested family. Here you can see the individuation of all different types of columns and pilasters. And here you can see the parametric modeling of octagonal pillar column. On the right side, you can see all the parameters and formulas. And here also the capital modelings. Same things for windows. We use the loadable families. Here you can see all different types of windows, and also a parametric modeling of 2 different types, the triangular grade windows and the round one. On the right side, you can see all the parameters in plan. For the sculptures that are decorative elements of the architecture, we use an external modeling. So starting from the point cloud, we import the point cloud of the angel sculpture inside Cloud Compare, and then use MeshLab in order to make the mesh modeling. Then we import the same mesh inside Revit. For the marble slabs, we use the point cloud as a base, and we use the common surface surface divide in order to make a division of the wall surface, and then we can apply all different materials. Here you can see the database of the materials for both for structure and marbles. The two main important marbles are Carrara and Verde di Prato. For the level of information, we can insert in the BIM platform also information about the building phases. Here you can see all building phases of the monument. And here you can see an application of each modeled elements. For example, pilaster and then arched wall. Here you can see the graphic expression of level of evolution of the baptistry. So we can create a lot of different views for each building phase of the monument. Same things for the thematic level regards the level of reliability. On the right side, in fact, you can see the validation of the model that is between the surface model and the point cloud using the Revit plugin point layout. And on the left side, you can see a graphic expression of this on the HB model, in which you can see three different levels for the level of reliability: low, medium, and high accuracy. Thanks. That's all.
Okay, thank you, Giorgia, for your presentation. Very interesting work. Do anybody have questions for Giorgia Potestà? I don't know if anybody used chat for asking questions. No, apparently no. And I would like, I'm sorry, but I missed some of your words because of the microphone issue. I don't know if it was only me or other people too. I would like to ask you simply about the last things you said of the reliability qualification of the reconstruction of the baptistry. Yeah. Can you please repeat what's the software that's been used to compare the point cloud with the modeling, with the 3D modeled
yes, architecture? Of course. We use the a plugin, a Revit plugin that is point layout that can compare the differences between the point cloud inside Revit model and the surface model.
Okay, so this comparison is performed only from a purely geometrical point of view, or also from a texture, for instance, point of view? Do you have a distance plotted in the colored map you've shown us, don't you?
Yeah, the color map expresses a deviation.
I didn't hear you. Can you please repeat?
Okay. The color map expresses the deviation, so the distance in centimeters between the point cloud surface and the surface of the model. Okay. Yes.
So and this is consistent. I imagine this is consistent with the accuracy of the scanner, which has been used for acquisition. So I think the time of flight of phase shift scanner has been used for the digitization. Am I correct? Do you know what scanner has been used?
Yes, Faro.
Faro?
Yes.
Okay. Faro Focus 3D?
Yes.
Yeah. So I guess that the green part of the map is below 5 millimeters, more or less.
Below 5 millimeters. Yes, of course.
Okay.
Yeah, yes. So the a little deviation between the modeled wall in H-beam and the wall inside the point cloud. So the dates that came from the survey.
Yeah. Okay. I got it. Thank you very much.
Welcome.
Other questions? We are early, so feel free to ask everything you want. We have time for the moment.
Yeah.
Otherwise, we can move to the following presentation. Okay, thank you.
Thank you.
And I'm now introducing Elena Verticchio. Okay, we see you. Good evening. And she will present us a work entitled Investigation on the Use of Hydrothermal Modeling for Paper Collections.
Exactly.
Okay, please share your screen.
Screen, yeah. I'm trying to, but it doesn't work.
Okay, we have time to try.
Okay, I hope.
Don't worry.
Okay, now it's working.
Okay, yes, it's working.
Okay.
We see your screen. Okay.
Good afternoon, everyone. I'm Elena Verticchio, and I'm a PhD student in Environment and Cultural Heritage at Sapienza University of Rome. This afternoon, I present an investigation on the use of hydrothermal modeling for paper collection, which was conducted in the framework of a collaboration between Sapienza and Tor Vergata University. In heritage conservation, it is fundamental to understand the interactions between the collections and the environment in terms of heat and moisture exchanges. In fact, climate is one of the major responsibles for materials deterioration. And in fact, it's important to study the environment in terms of the average levels and the variability of temperature and relative humidity. Relative humidity in particular is crucial in paper conservation, as it plays a key role in all the deterioration mechanisms affecting biological, chemical, and mechanical processes involving paper. Moreover, it is important to take into account that hygroscopic materials, such as paper, can act as buffers over the relative humidity fluctuations of the environment by continuously exchanging moisture with the surrounding air. The hygroscopic behavior of paper collection can be modeled by using hydrothermal tools, such as those of the HUM family, which acronym stands for heat, air, and moisture. These tools are mostly used to simulate the simultaneous heat and mass transfer through porous envelope materials, but they have already been successfully employed to account for the heat and moisture exchanges within paper repositories. Well, in this study, IDA-ICE software for the simulation of indoor climate and energy will be used coupled with the Untitled model for the monodimensional heat and moisture transfer across walls to model densely packed shelves made of paper books, as walls having the same absorption and diffusion properties as those of paper. To the author's knowledge, Untitled has never been tested so far in the modeling of the hydrothermal conditions within this kind of environments. Well, among the Untitled model governing functions, the absorption isotherms are calculated as a function of the relative humidity, which is here marked as phi, expressed as a value between 0 and 1. The equilibrium moisture content, W, is assumed to be sensitive to in fact assumed to be little sensitive to temperature changes, and the hysteresis is usually considered to be negligible for the scopes of this simulation. Well, the moisture storage curves of experimental data on historic and modern paper types were fitted using this equation and minimizing the discrepancy at phi equal to 0.5, which equals relative humidity equal to 50%. The benchmark value of 50% was chosen as it encompasses the condition recommended for the conservation of library collections, which are those targeted to avoid the risk of paper becoming brittle when relative humidity is too low, and the risk of biological colonization when relative humidity is too high. A literature survey was conducted to obtain at first an overview of the available experimental hydrothermal properties for common types of both modern and historic paper, which can be found in library and archival repositories. This table summarizes the values found for the bulk density, ρ, the specific heat capacity of the dry material, Cp, the dry thermal conductivity, lambda 0, the dry vapor diffusion resistance factor, μ, and both the free water saturation moisture content and the equilibrium moisture content at relative humidity equal to 80%. As you can see, reference 7 and 19 did not provide any value for Cp and lambda 0, while reference 6 considers standard values for paper. For this reason, reference 20 was introduced and used as a benchmark for the thermal properties of modern paper types. Well, to understand the influence of this kind of variability in the hydrothermal simulation of moisture gradients across a paper wall, a preliminary sensitivity analysis was conducted in order to identify the most relevant hydrothermal parameters in the simulation of moisture gradients across a single paper wall. The sensitivity analysis was conducted using the elementary effect method based on a Morris random sampling, where 10 elementary effects for each parameters were considered and 4 discretized levels to span within the ranges summarized here in this table. Here on the left, you can see a scheme showing the configuration of a paper wall model used for the sensitivity analysis. The paper wall model was attributed a thickness of 200 millimeters and was preconditioned to the initial condition of temperature 20 Celsius degrees and relative humidity equal to 50%. Then it was exposed to steady state boundary conditions fixed at temperature 20 Celsius degree and relative humidity 70%. And these boundary conditions were prolonged for 1 month. Here on the right, you can see the results of the sensitivity analysis expressed in terms of the mean and the standard deviation of the elementary effects calculated on the relative humidity gradients, on the relative humidity gradients computed across the paper wall. The results shows that only the equilibrium moisture content at relative humidity 80% and the moisture diffusion resistance factor are the parameters showing a significant but low influence on the given output. For this reason, it was reasonable to assign the paper wall model with a high resolution inside showing 63 equally spaced sublayers. These values and using the Amwell model to simulate the hydrothermal exchanges inside. First, here the hydrothermal behavior of the paper wall model was tested in steady state conditions where boundary conditions were fixed to, again, 20 Celsius degrees and relative humidity at nodes A and B, equal to 70%. As you can see from the carpet plot on the right, the relative humidity values obtained within the paper wall model evolve slowly, showing significant variation only after one week of prolonged exposure to the boundary conditions, and reaching the full equilibrium between the bulk and the surfaces only after several years. Then the influence of the number of sublayers used in the paper wall model was tested in steady-state boundary conditions. Here you can see from the histograms the relative humidity values obtained at the same depth within the paper wall model by using a different number of sublayers. For sublayer numbers 63, 31, 15, and 7, the associated thickness was 3, 6, 13, and 29 millimeters, respectively. As you can see from the picture, a significant underestimation of the computed internal gradients can be introduced because of the averaging operation over a too large sublayer thickness, especially in the most external sublayers. Then the influence of the number of sublayers in the paper wall model was tested also in dynamic conditions by using the high-resolution paper wall model with n equal to 63 equally spaced sublayers. The model was tested in the simulation of relative humidity at different depths, where the boundary conditions were temperature equal to 20 Celsius degrees and relative humidity periodically ranging from 30 to 70 relative humidity at weekly, monthly, and seasonal frequencies. As you can see, only the first 5 sublayers, corresponding to the first 15 millimeters under the wall surfaces, are the most responsive one to the external boundary forcing. Here in the graph for the seasonal frequency, for the sake of brevity, only the sublayer differing more than 10% from the preconditioning values were represented. Well, even if the high-resolution paper wall proved to provide more accurate results, it may nevertheless increase too much the computation effort when included in whole building simulation models. For this reason, it was proposed and tested a simplified model, which was composed of unequally subspaced sublayers with the 5 more external sublayers under the nodes A and B, with thickness equal to that of the high-resolution reference, which was around 3 millimeters, and then the bulk volume was divided only in 3 bigger parts. It was found that the number of the most internal sublayers does not have a significant influence of the output of the relative humidity gradient here represented. For the high-resolution reference, the relative humidity gradient was calculated as the difference between the relative humidity at the bulk of the paper wall model and the relative humidity at the most exterior sublayer called L1. In the simplified model, the relative humidity gradient was calculated as the difference between L in and LA, here marked. The results of the simplified model were tested in comparison with the high-resolution reference, And here you can see two scatter plots representing the relative humidity gradient obtained with the high resolution reference, together with those obtained with the simplified model. As you can see, both in static and in transient conditions, the simplified model is able to reproduce the behavior of the paper wall model. And thus, it is reasonable to conclude that it can be used as an alternative to the high resolution reference in whole building implementations. Well, to summarize, in this presentation, the capability of the Humboldt model coupled with IDAIs was investigated in the simulation of the monodimensional heat and moisture transfer across a single paper wall model. At first, a literature survey provided the hydrothermal properties measured in paper, and then a sensitivity analysis was performed in order to identify the most influencing parameters on the relative humidity gradients inside the wall. And it was found that the equilibrium moisture content at 80% relative humidity and the moisture diffusion resistance factor were the most influencing parameters on the given output. Then the number of sublayers used in the wall model was tested in both steady state and transient conditions, and it was found to significantly affect the relative humidity gradients, the relative humidity outputs, so that the values obtained at various depths within the paper wall. Finally, a simplified paper wall model was proposed, and it was tested, proving that it was able to keep the accuracy in the results while reducing the computation effort. With this, I concluded. So I hope you enjoyed the presentation. If you have any question, I'm here to answer.
Okay, thank you. I definitely enjoyed your presentation, and I think all the rest of the audience did. Any question for Elena Verticchio?
Yes, hi.
Please go on.
Yeah. I work as a paper conservator, and I wanted to ask you, thank you so much, Elena, and I wanted to ask you what your research can help us in the field of paper conservation.
Well,
thank you so much.
Thank you for your question. Well, this study was preliminary to use these kind of models within whole building dynamic simulation. These kind of tools are very useful in the preventive conservation of heritage collection, because they can provide the expected indoor conditions in terms of temperature and relative humidity within the modeled environment. This means that not only you can evaluate the future conditions within an environment, but you can also test and hypothesize different retrofit solutions in order, for example, to fix problems and to improve the conservation conditions for the heritage preservation.
Thank you so much. Thank you.
Okay. Other questions? I have one myself, if I can. You mentioned the necessity of devising a simplified model because of computation time. I must confess I've never conducted you mentioned, so I'm curious about the computation time that may be involved in this kind of simulation.
Well, of course, it depends on the computer, because of course there are some differences that are related to the computer power, but nevertheless, when implemented in complex buildings such as palaces or many floors buildings made up Okay, so it could be very difficult to for the simulation software to run all the equations which describe the behavior of the walls, the roof, the pavement. So it may be sometimes necessary to simplify a bit
the model. Okay.
At least, yeah, the less influencing parts of the model.
For an average complexity building, are we talking about hours of computation time or days or what?
Well, again, it depends. Sometimes even less. But one must be aware that the complexity of the model is one of the key elements in the resulting time of simulation.
Okay. I also imagine that in case you have to optimize and so run multiple scenarios, the requirement is even more strict. And so,
for example, in the sensitivity analysis, many simulations were run. Exactly.
Okay. Thank you very much. Any other question? No. Okay. Thank you, Elena, for your presentation and your answers. Now I will introduce the next presentation by Maccheroni. I cannot see the name here.
Yeah, Dario, hi.
Okay, Dario Maccheroni, welcome. And the title of the presentation is Sustainable Lighting for Cultural Heritage, a pilot study for evaluation the exhibits display inside historical buildings. So,
okay,
have already shared your screen. Okay.
Okay, so I hope you can see the first slide.
Yes, we can.
Okay, great. So, good afternoon. I am Dario Maccheroni, and together with Giuseppe Tambellini and Professor Giacomo Salvadori of the University of Pisa, we are going to present the findings of our research entitled Sustainable Lighting for Cultural Heritage, a pilot study for evaluating the exhibits display inside historical buildings. So worldwide, but in particular in Italy, it often happens that historical buildings are converted for different purposes once their original one comes to an end. So the most common refunctionalization is linked to tourism and cultural heritage display. It may appear that historical buildings are well suited for this use due to their picturesque look and, what is more, the fact that reusing historical buildings helps fighting the degradation while promoting art and culture. However, this operation implies some difficulties. First of all, historical buildings may not be completely accessible by people with disabilities. Secondly, the energy consumption of this kind of buildings must be carefully evaluated. And finally, because promoting art and culture has a deeper meaning. In fact, for instance, the Article 2(b) of the decree of the Italian Ministry of Cultural Heritage states, the national museal system aims to guarantee access to cultural heritage and develop its conservation through the definition of uniform and confirmable modalities for the conservation and enhancement. This means that if a building is designed or converted in an exhibition space, it must guarantee that exhibits can be admired without putting them at risk. In order to do that, an adequate display setting should be designed. However, when historical buildings are used as an exhibition space, they often fail to achieve the adequate display settings. In fact, historical buildings often have large windows which provide large and uncontrolled amount of daylight, and they often do not have appropriate window frame or insulation. As a matter of fact, lighting and thermohygrometric conditions are the main factors of risk for exhibits in terms of conservation. Daylight in particular, being rich of UV and IR radiation, is the most hazardous light source. Nevertheless, from the visual comfort point of view, it is the most favorable one. And still, from the point of view of conservation, it is important to consider that light can deeply influence the visitor's enjoyment and their understanding of the artworks. Moreover, it can influence the visitor's visual and color perception. Therefore, lighting must always be carefully studied inside the exhibition spaces. So this research ponders the sustainability of two different approaches to the analysis of cultural heritage lighting. The first one is based on daylight factor, while the second one is based on annual measurement campaigns. Sustainable refers to the usage of resources in a way that they are not depleted or permanently damaged. As far as cultural heritage is concerned, the exploited resources are the exhibits. Light is necessary for the visitor to see, but at the meantime, it can harm the exhibits. The two different approaches differ in cost, time, and accuracy. In order to assess their actual sustainability, all these aspects must be considered alongside the conservation-related ones. The comparison will show the advantages and the shortcomings of both methods, and it will provide suggestions on which one to use depending on the aim of the analysis. The daylight factor-based and the measurement-based approaches were applied to a case study, the Cetacean Gallery of the Monumental Charterhouse of Calci near Pisa. The gallery was chosen for the architectural value of the host building and for the massive presence of large full-height windows on both north and south-oriented facades. The analyses were run both with software simulations and on-site measurements. To validate the model for the simulations, the horizontal illuminance was recorded using a light meter. So the Monumental Charterhouse is located in Calci near Pisa. It was founded in 1366 as a Carthusian monastery, and nowadays the original structure has almost been completely lost. The major modification started during the priorate of Alfonso Maria Maggi between the 18th and 19th centuries, and followed during the 20th century due to First and Second World Wars. In fact, during the First World War, the Charterhouse was occupied by the 32nd Field Artillery Troops. Then it was converted into a backup field hospital, and later into an emergency storage for artworks in case of war, and this was in 1939. Finally, in 1979, the last monks left the monastery and the Charterhouse was partly donated to the University of Pisa. In 1981, the University of Pisa inaugurated the Natural History Museum, and nowadays the Charterhouse hosts the Natural History Museum and the National Museum of the Charterhouse. And as you can see from this picture, this Cetacean Gallery was built on the second floor of the former barn of the monastery. So the rectangular plant measures 7 per 110 meters for a total floor surface of 700 square meters and a volume of 3,500 cubic meters. The space is articulated in 21 bays marked by brick columns. Each bay presents 2 large and full-height windows, one oriented north and one oriented south. In addition, there is a wide arched window on the west terminal wall. The ratio between the windows and the floor area is 67%. The gallery hosts the most important Cetacean skeletal collection for number of species in Italy, and it is the only collection in the world displaying at the same time skeletons of the 3 biggest non-extinct animals. And the collection is formed by 28 skeletons, 11 life-size models, and 36 scaled models, and 9 thematic areas. So for what concerns the daylight factor-based approach, the UNI 13 Part 2 2019 version provides a procedure to evaluate the energetic and environmental sustainability of buildings. The procedure was developed by Ithaca, the Italian institute dealing with tenders for sustainable development. This procedure suggests daylight factor upper limits depending on the room intended use. For museums and exhibition halls, no values are provided. Nevertheless, in the previous version, a daylight factor of less or equal to 1% was suggested for this cloistery. For what concerns the measurement-based approach, the standards to refer to are the EN 16163 and the decree of the Italian Ministry of Cultural Heritage. These standards explain how to measure lighting for cultural heritage, and they suggest two metrics to monitor its conservation. These metrics are the maximum illuminance and the total annual exposure. The upper limits depend on the photosensitivity of the exhibits, and they vary between the Italian and the international standards. As far as bones and skeletal specimens are concerned, the Italian standard is the more restricted one, and it indicates the maximum illuminance of 150 lux and a total annual exposure of 500,000 lux hour per year. The daylight factor can be calculated using one of the equations provided by the Italian standards, where epsilon is the window correction factor, tau is the transmissive index of the windows, A is the surface of the windows, psi is the correction coefficient, S is the sum of the interior surfaces, ρ is the average refractive index of the interior surfaces, E with the index I is the illuminance inside the room, shaded from direct sunlight under overcast sky conditions, and E with index O is the illuminance outside measured near the windows. The advantage of the daylight factor approach is that the calculations are easy and they do not require specific surveys. In fact, the only information necessary are the geometry of the room, the geometry of potential obstructions, the geometry of the windows, their transmission index, their surface, and finally the refractive indexes of the interior surfaces. This information can be easily acquired. Moreover, the indexes are tabulated depending on the materials and their colors. It should also be noticed that the daylight factor equation does not depend nor from the window's orientation nor from date or time. In addition, the indoor illuminance must be recorded under overcast sky conditions. However, the actual representativeness of the overcast sky for the site in exam is not implicit. In the case study, the daylight factor was calculated using both equation and software simulations. The measurement-based approach provides more accurate results than the daylight factor one. However, in order to evaluate the total annual exposure, an annual measurements campaign is required. For the pilot study, it was impossible to directly measure the total annual exposure, as it would have required to perform an annual measurement campaign. In fact, that is the main shortcoming of the measurement-based approach. However, under certain conditions, the annual measurement campaign can be substituted with software simulations. In the case study, the total annual exposure was calculated using software simulations. In order to use software simulations instead of an annual measurement, it is necessary then to develop a model. The model must accurately represent the examined room, its geometry, materials, characteristics, colors, and surfaces. Finally, the model must be calibrated. This can be achieved by running some pilot simulations and then confronting the results with on-site measurements. The measurement campaigns needed for the calibration are considerably shorter than the previously mentioned annual ones. In the case study, the simulations were run using climate-based data. meaning that simulations are based on the actual meteorological conditions of the site in exam, and therefore they can deliver reliable results. The results obtained in both approaches suggest anyhow that the Cetacean gallery is overlit. However, the results obtained using the daylight factor-based approach provides fewer information. They give no insights on the actual lighting conditions of the exhibit. This means that the daylight factor-based approach is not well suited for in-depth analysis, even if it's acceptable for first instance evaluations. On the contrary, the measurement-based approach provides useful information that lighting designers can compare to standards requirements. Still, for this approach to be applied, one would need to accept the costs and the length of the annual measurement campaigns. It is true that this step can be circumvented using reliable simulations, but however, these must always be validated. Therefore, a measurements campaign cannot be totally avoided. In the case study, the accuracy of the model was validated using on-site measurements. Applying the daylight factor equation using the recorded luminance level, one would obtain a daylight factor of 9.93%. In order to evaluate the accuracy of the approaches, the error between the daylight factor equation result, the simulation result, and the measurements was calculated. These errors demonstrate that climate-based simulations are reliable, therefore they can be used for the estimation of the total annual exposure without recurring to annual measurements. Nevertheless, on-site measurements are necessary to validate the simulation's accuracy. So finally, the simulations demonstrate that the exhibits inside the Cetacean gallery of the Charterhouse of Calci are in danger. The deviation from the limits set by the standard is extremely relevant. Therefore, an intervention to secure the exhibits is urgent. The pilot study suggests that both the daylight factor-based and the measurement-based approaches can provide information on the exhibit's lighting conditions. However, it is not advisable to use the daylight factor-based approach for in-depth analysis due to its oversimplifications. On the contrary, for such analysis, the measurement-based approach is recommendable, even though it requires major cost for the measurement campaign. Considering the overall sustainability of the two approaches, it is clear that the measurement-based one is the most favorable. The economic costs are compensated by the accuracy of the acquirable data. In fact, it is fundamental to recall that sustainable lighting cannot be confined to the economic sphere, but it must consider the conservation of the exhibit considered as resources. The measurement-based approach can provide more accurate information than the daylight factor-based one. Therefore, it can help monitor the exhibits more adequately. So finally, the authors believe that a scientific standardized procedure to evaluate the exhibit's display conditions and to compare potential intervention is desirable. Such a procedure would allow to follow a repeatable approach, meaning that various courses of action could be compared to find the most adequate one. The procedure should rely on climate-based daylight simulations and on-site measurements to validate these provisions. It should consider the requirements both for conservation of the exhibit and for the comfort and safety of visitors. So with this, I conclude my presentation. Thanks for your time. Now, I believe the microphones are open for any kind of questions you can have.
Okay, Dario Maccheroni, thank you for your interesting presentation. I ask the audience if somebody have a question for Dario Maccheroni. Okay, apparently there's no question. I don't have any myself.
Okay.
So thank you again for your presentation.
Thanks for your time. Thank you.
So let's move on with the next work, which will be presented by Gianluca Cadelano. I don't know if he's online.
Yeah, Gianluca Cadelano here.
Okay, thank you. And the title of the work is Assessing the Indoor Conditions of a 3rd Century AD Roman Domus by Dynamic Energy Simulation and Comparison with Vitruvian Hypothesis, the preliminary findings. Okay, we can see your screen.
Okay.
And you can begin with your presentation.
You got my screen at full screen mode, right?
Yeah, you should switch to full screen.
Okay. So,
okay, right.
Good, thank you. So my name is Gianluca Cadelano. I'm a researcher at CNR, and my field of interest concerns microclimate and conservation of historical buildings. This usually involves on-site inspection using IR tomography or other methods to evaluate things such as fresco detachments or to assess the best microclimate condition for a collection, for instance. But this time it's a little bit different because what I'm going to present to you today is a case study where the historical building no longer exists, almost. All start from one of the many unanswered questions that the archaeologists still have on Roman technology and culture. Concerning the architecture of private buildings, over time the Romans developed housing solutions that we find repeated several times in excavation in urban context. These occurrences, which we could define building archetypes, clearly share a set of rules or best practice. We are therefore not so surprised when we read ancient authors such as Vitruvius. In the famous De Architectura, Vitruvius describes the theoretical model of the atrium and the peristyle house. Vitruvius also describes the position that each room of the house should have respect to the cardinal points and seasonality. In particular, Vitruvius suggests how the room in which to use the banquets, known as triclinium, should have changed from season to season. Despite this, when Domus is excavated, it is not always possible to identify with certainty all the rooms and their function cited by the Latin author. For example, in northern Italy, when the climate is colder, it is found in archaeological remains the presence of actual domestic heating systems, which were added to other simple systems consisting of movable braziers. The heating system was strictly connected to a special room that could be found in the Domus, the room dedicated to the sauna. The heat was produced by a fireplace housed in the adjacent room called prefurnium. A servant was in charge of providing charcoal to keep the fire going while the inhabitants of the Domus were in the other room enjoying the sauna or taking a warm bath. The hot air flowed into a gap under the floor of the heated room called hypocaustum. The hot air could be conveyed through pipes placed inside the walls to reach other rooms in the house. Otherwise, the heat from the sauna room could indirectly heat other nearby rooms. After this necessary introduction of some building aspects of Roman private housing, here is our case study. It is the well-known Domus of Piazza Nogara, the remains of which can be visited in the basement of Banca Popolare di Verona, in the historic center of the city. The Domus was built in the Augustan age and has undergone several renovations over time, up to the 6th century, where it was abandoned following a fire. In this study, we look at a specific period in history, namely 3rd century. The Domus develops around a central courtyard, and two main districts can be distinguished: the residential sector, where the banquets were used, and the service rooms, dedicated to the servants and the kitchen. According to the dictates of Vitruvius, the rooms here labeled 13 and 14 are adjacent to the kitchen and are respectively the room of the prefurnium and of the hypocaustum. The fireplace and the pile that supported the heated floor are still there. However, in the short elevation that unfortunately has come down to us, no traces have been found of hydraulic pipes to supply the water of the balneums, and not even the channels for the aerating system inside the walls. Therefore, an indirect heating system is hypothesized due to the high temperature inside the sauna, which by heating the walls could have had a thermal effect on the nearby rooms. Where the archaeological studies have stopped due to lack of further material evidence, a small step towards understanding the Roman construction principles has been attempted with the methods that I will describe. These methods are not typical of the historical or archaeological research, but are borrowed from modern building engineering. Through dynamic energy modeling and regulatory standards for evaluating the thermohygrometric comfort in indoor environments, we try to understand whether or not the Vitruvius rules were applied in the Domus, and if they actually made sense from a microclimatic point of view. Okay. So, we use dynamic energy simulation. That's basically, it's a piece of software able to replicate the geometry of the building and its thermophysical properties in order to model its energy and thermal behavior under imposed boundary conditions. Like all computer codes, there are input parameters which are necessary to describe the building through algorithms. In general, the more accurate the inputs, the more reliable the outputs. Now, we will see the many inputs and how we tried to deduce them to the best of our possibility based on the few remaining ruins of the Domus. Let's keep in mind that we want to model the Domus as it was in the 3rd century under the boundary condition of the 3rd century. The first input is the building geometry. The photo on the top left is the current situation of the Domus. All internal spaces and subdivisions are recognizable. The door cells are still in place. The thickness and the stratigraphies of the walls have been measured and catalogued. Regarding the missing elements, such as roofs and windows, previous studies provided a possible reconstruction made on historical basis. When considering climatic parameters for modeling the behavior of modern buildings, we usually refer to meteorological databases, which often dates back a few years ago from now. In some contexts, it is necessary to use fresh measure annual data for the purpose to avoid errors due to the obsolescence of these databases that are only a few years old. Add to these sudden climate changes as the one that all of us are directly experiencing nowadays. This is just to give an idea of what kind of madness it may seem to be claiming to get decent climate data hundreds of years old. Nevertheless, fortunately, very accurate studies have been concerned with reconstructing the temporal sequence of the climate over the centuries. This work is truly immense and includes interdisciplinary studies ranging from archival research to the knowledge of ancient measuring instruments to geological and biological evidences. This is the limit of our knowledge, but still allow us to have some data for modeling. Data are certainly not perfect, but at least are usable, very usable to make consideration that are not completely meaningless. Concerning the thermophysical properties of the envelope, the situation is a little better because we have some remains actually. This fact is fundamental because obviously there are no databases or stratigraphies as for modern buildings. However, it was not possible to make direct measurement of the thermophysical properties on samples or in the field due to issues related to the preservation of the domus. For the reason, indirect approaches were adopted. For instance, the properties of the structural elements were obtained by estimating the envelope composition derived from the proportion amongst the raw material constituting the walls. Because we can still observe their sections. The modeling of the domus made it possible to obtain a reconstruction of what should have been the temperature inside the various rooms over the course of the year in the historical period we consider. This allowed us to draw two interesting information. First, the system, consisting of room 13 and 14, was in fact able to rise the temperature up to 50 degrees Celsius. So it is confirmed that the room 14 could have been used as a sauna. As regards the dual function of the heating system for domestic heating, it was observed that this can be considered only partially true. In fact, it appears that only the immediately adjacent rooms are affected by the indirect thermal effect, leaving all the other rooms substantially untouched. Further consideration have been made using another tool borrowed from modern environmental engineering. The studies of Professor Fanger, implemented by widespread international technical standards, allow us to predict the comfort perceived by people under certain thermohygrometric conditions. An empirical formula considers a multiplicity of parameters, including heat exchange condition, humidity of the environment, the physical activity, and the clothes worn by the inhabitants, by the people. The result is a quantitative evaluation expressed by two parameters, PPD and PMV. The first represents people dissatisfaction. The second one is the sensation, as a perceived level of heat or cold. The metabolic rate for this calculation was imposed according to the tables in the regulation, considering a physical activity somewhat comparable to the one of the people in triclining. The evaluation of the airspeed took in consideration the building reconstruction made on archaeological basis from the previous studies, because the actual elevation of the wall of the domus no longer exists. Specific consideration have been made to obtain the insulation value due to the garments. The values found in the tables of the regulation were not so useful because they are in fact applicable only to contemporary and Western style of clothes. So in an effort to obtain reliable values, two types of bibliographic sources were considered. Those concerning the fashion of ancient Rome and the scientific literature that took into consideration the application of the Fanger method for countries of Middle East or North Africa. In addition, aspects such as the geographical location of the domus and the seasonal variation in the way of dressing were considered. Here are represented the levels of comfort perceived by inhabitants of the residential sector of the domus in the cold season of the 3rd century. With the exception of room 12, which is heated indirectly by room 13 and 14, in the winter period, all rooms are considered very uncomfortable by modern evaluation standards. Only room 8 or 9 have minor advantages due to their orientation. These rooms, in fact, are open to the central courtyard facing southeast. Here are represented the levels of comfort perceived by inhabitants of the residential sector of the Domus in the spring season of the 3rd century. So it appears that the transition from room 6 to adjacent room 7, 8, 9, 10, and 11 appears indeed to be a factor in improving perceived comfort. Once again, due to the effect of the heated room, the most preferable comfort conditions are still in room 12. Here are represented the levels of comfort perceived in the summer season of the 3rd century. Room 12 now is not comfortable at all during the summer due to the overheating effect caused by the nearby sauna. Comfort conditions during the warm season are very good in all other rooms of the residential sector, especially in room 11. So concluding, the question is, can the energy modeling of a building be useful as a tool for archaeological research? Well, despite the numerous difficulties encountered, evaluating an energy model as reliable as possible within the limits of our knowledge, of course, this preliminary study has helped to formulate somewhat more reliable hypotheses on the intended use of the internal space of the Domus, and evaluate the effect of the hypocaust as a heating system. So I would say yes, as long as we take into account that there are always some gray areas that we probably will never cover. And considering also those non-technical nor engineering aspects, more social parameters, such as the real perception that the Romans had about comfort, that will probably be much less sensitive and more accommodating our modern standard we are used to, and this is something that we can never measure, of course. So I invite you to ask questions. Otherwise, I thank you very much for your kind attention and wish you a pleasant continuation of the meeting. Thank you.
Thank you very much, Gianluca. I thank you for your interesting presentation. Does anybody have questions for Gianluca Cadelano? I have a curiosity, if I'm allowed to. I would like to know if you have considered possible different heat sources located, spread on different rooms of the house, except for the one coming from the system you mentioned at the beginning of your presentation.
Yes. We know that probably movable braziers were used. So they were placed inside the residential sector, but since the rooms were not always used on a regular basis for a specific purpose, it's not so easy to locate these braziers in the model.
Okay, so anyway, in the images you showed us,
they are not considered for
okay, they are not considered.
Okay. Of the simulation, they were not considered.
Okay, thank you.
Welcome.
Other questions? No. Okay, thank you again for your presentation. Very interesting. And let's go on with the next one. Just 1 second. We have a presentation from Elena Lucchi.
Yes, I'm here.
Okay, you are online.
Yes.
The work is entitled, which is being presented by Elena, is entitled A Conceptual Framework on the Integration of Solar Energy Systems in Heritage Sites and Buildings.
Okay, thank you very much. My name is Elena Lucchi. I'm a senior researcher at EURAC Research Institute in Bolzano, and this paper has been made in the framework of the European project BIPV Meets History that I'm coordinated on the integration of BIPV systems, so photovoltaic system in historic buildings and landscape. The aim of this research is to define a conceptual framework on the integration of the renewable energy sources in the retrofit of heritage building and site in order to balance the preservation of heritage value, the reduction of energy consumption, and the increasing on comfort, architectural and technical quality, as well as environmental sustainability and economic cost. In the next slide, you can see the methodology of the work is a literature review, and we look for the international research project on this topic, academic studies related to scientific papers, conference proceedings and books, as well as literature review on grey literature, so guidelines, technical reports, awards, and internet sites to have a complete vision of this topic. The keywords we use are related both on technical keywords such as renewable energy sources, solar energy, solar architecture, BIPV, so building integrated photovoltaics system, and BIST, so building integrated solar thermal system, as well as the word from the heritage conservation, so historic or historical buildings, protected building, heritage, landscapes, and so on. In the next slide, we define our work in three parts. The first one is related to the research projects that are dealing with these topics. The second part is related to the awards, and the third part is related to the guidelines. First of all, research project. We found 20 research projects, international, European and local research projects on this topic in the last 20 years, more or less. And the first aspects are related to the acceptability of photovoltaics technology in heritage context. The more famous research project is named PV Accept, that refers not only to heritage or historical buildings, but to the retrofit of building with this kind of technologies. After that, the International Energy Agency defined two projects, the task 37 and the task 31, related to the development of a solid knowledge on the integration of solar technology in existing building, also demonstrating this possibility and this advantage with several case study on energy retrofit. In the next slide, in the last 10 years, several projects have been developed on this topic. In the first step, the project are referred mainly to heritage or historical buildings, so not focused on the integration of solar technologies, but on the retrofit of historic and historical buildings, with a specific task dedicated to the integration of this technology. In several projects, I think that you already know, for example, New for Old, Securba, or Tree and Cult, that are referring to historic building, or Ephesus, that was referred to the integration of this technology at urban level. So starting from the historic building, the topic was developed at urban urban level and heritage side, developing tools or methodology for the calculation of the solar potential, as well as the pilot project to see how this technology can be applied on this kind of heritage buildings. The most recent projects are related to the definition of a legislative framework or the development of the value chain in the building sector and in the photovoltaic sector among the different stakeholders, so public authorities, heritage authorities, universities, research institutes, and PV companies, and the impact of this technology on the electrical grid. In the next slide, you can see this project is you can just go in slide for slide. I create several tables on it with the acronym of the project, the program, the years, and the aims. You can go further in the fourth slide. So this one, the other one, just to understand that there are several projects on it. Regarding the awards and prize, there are only 5 prizes dedicated to solar architecture in heritage context, or with a focus on heritage context, and they are related more to case studies, but also to products, so BIPV and BIST products. And then the next slide, you can see this award that started. The most famous, I think, is the Eurosolar European prize. That is the oldest one, but also the Swiss Solar Prize is very, very famous, and they have several heritage building awarded with this prize, this award. The interesting things is that in the last edition of this Swiss prize, no project was awarded because they can't balance heritage conservation with energy efficiency production. So it's a very difficult topic. In the BIPV Meets History project, we develop an award that will be awarded in the end of November, and we have more than 90 case study, but only the 50% was on BIPV technology. So in Italy, the concept of solar architecture is mainly devoted to the use of biophilia or bioclimatic aspect than PV technologies. Finally, regarding the guidelines and policies, there are, I think, 50 guidelines at national level, for example, in Italy or in France, in Austria, and Germany, at regional level in several countries, also defined but private association, for example, in UK or in Ireland, or local guidelines in Sweden, for example, or in US, that refers specifically to specific constructive technologies. All of these guidelines have common criteria, and the aesthetical impact is the most important aspect. Only in few guidelines, the energy efficiency and the energy production is considered. In the next slide, you can see that there are 3 mainly criteria that are referring to the type of project, to qualitative criteria, and to quantitative criteria. Localizing criteria, the next slide, refers to the kind of building that can be integrated with the photovoltaic system, and in many cases are mainly new buildings, not historic building, or addition on historic building, only in few cases there are rules for heritage building, especially for listed building, but in many cases, as in many countries mandatory, there are several rules for traditional building and historical buildings. The next slide, please. Qualitative criteria are the most important part. They refer to the criteria of architectural restoration. So mainly the most important aspect is to conserve the heritage building or the heritage feature, the original material, without having a permanent transformation of the historical fabric. And in many cases, distinguishability and reversibility and compatibility are the most important aspect that have to be guaranteed applying BIPV technologies. The next slide, just a summarize of the aspect related to the reduction of the aesthetical appearance of these technologies. So BIPV technologies can be applied on historical building, but not with a low impact, visual impact reduction, the aesthetical appearance mainly. Finally, quantitative criteria refers not only to the production of energy, but also to the life cycle assessment of energy. But only few guidelines consider this aspect. I think only 5 guidelines on 50 guidelines. So this means that the guidelines refers mainly to the conservation aspect than to the energy aspect or the engineering aspect. The last slide, just to conclude. In the background, as I tell you before, the background refers mainly to conservation, to the energy efficient. Right now, there are height barriers to the acceptability of these technologies, but in many cases, these barriers are referring to the absence of the knowledge of the innovation possibilities of this system. So this system can be completely customized. There are several colors, low visual aspect, low visual impact, and in the best important problems refers to the legal framework. Especially in Italy, we are developing a questionnaire survey to understand the most important barriers, and the legal framework and the authoritative process are an important aspect for design to apply these technologies. Finally, we need a lot of training to teach the people what BIPV technologies are, updated guidelines, because many guidelines refer to 10 years ago, so the innovation in the production is very high in the last 10 years, and architects, mainly also engineers, needs several pilot projects and technological platform to see good example. In the last slide, you can go throughout this slide very fast. I show just several examples. This is the Doragno Castle in Switzerland with a roof. The roof was not usable, was not secure, so they decided to have a massive production of electrical energy, use BIPV technologies. This is an Italian case, is Villa Castelli on the Como Lake, and in the next slide you can see the roof was completely restored using transparent BIPV technologies. This project was developed with the help of the heritage authorities, so the system was designed ad hoc starting from the nautic sector. the next slide is a very new project, a very recent project in Venice, as you can see in an island near project. This is the first step with a massive use of BAPV, so not integrated technology, blue technology, and also with a massive construction. But after the discussion in the next slide with the heritage authorities, you can see the new technologies. This is the original roof, and in the next slide, the construction work, and finally the works using the hidden color BIPV technology. So the next two slides, you can see the roof in the roof first, and the building in the area in the final slide. Another project that is a Switzerland project, in this case in Alpine building, a Maso, was built this shelter that refers to the use of hidden color BIPV technologies. And in the next slide you can see the image, the actual image of this building. Another project that was presented in this contest award is named La Capanna, is in Italy, near Florence, and in this case they built this roof. The building was already built, but the roof was completely destroyed. So they decided to build this new roof with the BIPV technology, with a very detailed study to not have the visibility of the system all around from the landscape. And finally, as is Florence Heri-Tech, I want to present the last case study that is a bridge near Pisa with the integration of photovoltaic system. That's the last slide. Thank you. If you have any questions, I'm here.
Okay, thank you very much for your presentation. Questions for Elena Lucchi? May I ask if one of the outputs of the project you told us about involves the production of guidelines or technology guides for practitioners in order to use some specific solutions that people may be not aware of, just in case that technicians do not know some technologies. A guideline could help them in choosing a new solution that they do not yet know.
Yes, we are developed these guidelines with Regione Lombardia, because the project is in Italia, Switzerland, and the case study is on Regione Lombardia, and the Lombardy region is a partner on the project. So we are developing the guidelines, and Lombardy region will applicate it in a real way. We are developing this using the most innovative technologies. And also Switzerland have already guidelines, very innovative guidelines, so we are trying to transfer this aspect also in the boundary area, to not having different rules in Italy and in Switzerland.
In Switzerland. Okay. Okay, thank you very much. Thank you very much. Other questions? No. Okay. Thanks again.
Okay.
And let's move to the final presentation, to the last presentation of this session. This one will be delivered by Alexandra Marco. Is she online? I don't know. Apparently, is there any other author of this presentation? The title is X-ray computed tomography for the study of mural paintings, the case of Santiago Church. Oh, it seems like none of the authors is online. May I ask Silvia to check? Okay, just a second, because it looks like one of the others is online, but probably away from keyboard. Let's just take a short break so we can contact the person. Just a minute. Maybe Alexandra Marco is away from keyboard because she was supposed to deliver her presentation at 4 p.m. So we have...
Lapo, sorry, this is Alexander. I see a message from Alexandra. She's there in front of the computer, but it seems she cannot activate the microphone. That's the problem.
Ah, okay.
Alexandra, let's try to get out and get in back. Sometimes it works.
Put sound, yes. I'm reading the chat right now. Thank you, Alessandro.
You're welcome.
Yes, you should leave the... Okay, she's left the meeting. Let's wait for her to come back. Okay, we can see you. Try to switch on your... Okay, we can also hear you now.
Yeah, okay, thank you, sorry.
No problem. Sometimes it happens. It usually happens to me during lessons to the students, so no problem at all. Okay, can you please try to share your screen so we can see your presentation?
Let's see.
you should have a button on the bottom right of the screen, of the Google Meet screen, for sharing your screen with written present now.
Sorry, I just bought this computer.
Okay.
And it's an Apple, and it says it doesn't have permission to do anything. So I'm trying to give it permission. Sorry. Let's see. Now, screen. Okay. Can you see my PowerPoint?
Yes, we can see your screen now.
Okay.
Okay.
Okay. Thank you. Sorry. Ciao. Hello. I thank you, first of all, for the opportunity to present part of my ongoing investigation. My presentation is about the use of X-ray microcomputer tomography in mural paintings. There is currently a problem of dark stains in mural paintings that are common to several Romanesque granite churches with 15th and 16th century paintings. At the moment, neither the origin of this pathology, neither a way to remove it without damaging the mural paintings was found. That is the scope of my PhD investigation. A multidisciplinary approach is needed, from microbiology field to the characterization of the paintings and granite constituent materials. To do so, several techniques were used. This is a map I'm constructing. This is a map I'm constructing of the Iberian Peninsula and the location of every church with dark stains in mural painting of the same period. As you can see, they are all located in the northern Portugal region. However, it came to our knowledge that there might be the same problem in some churches in Galicia, Spain, where the terrain and weather are very similar to ours. It's in need of in situ verification. The churches you saw on the map earlier are all my theoretical case studies. They are already more than 30. And what you see in this slide is just a small sample of them, so you can observe what are the stains like. You see, these are the stains that almost block the vision of the murals. Here. My practical studies are these three, where I can collect samples and study to a greater extent. The Church Santa Marinha in Vila Marim, Nossa Senhora da Guadalupe Church in Mossos, and Santiago Church in Folhadela. They're all in the same district, Vila Real, Portugal, of course. Santiago Church, this one, is where I used the micro-CT technique. As you can see on the picture at the right here, there are at least 3 different layers present, which might or not be campaigns. Campaigns are frescoes made in different times, centuries. From this location here, we collected the sample for this investigation, a fresco mural painting with a mortar mixture of lime, that is calcium carbonate, and fine sand river. X-ray microcomputer tomography, or micro-CT, to shorten it, is an equipment that analyzes a sample in 360 degrees, producing data that can be used to build a 3D reconstruction of the object or sample, showing the different structures and layers and its pore distributions. It can show the defects, cracks, earlier restorations, etc. In northern Portugal, the mural paintings have almost exclusively one mortar layer, due to the lack of lime ovens in the region. A mixture of lime and granitic sand made of a finer sand with smaller grains. The different size grains are due to the existence of several minerals in the granitic sands, such as silica, quartz, biotite, among others, depending where they are extracted from. 3 layers, as you see here, 3 layers were visible performing the CT scan, since they detach themselves due to the lack of adhesion of the substrates. However, one stratum in the first layer here, and another one in the second layer here, was made perceivable with the 3D render volume, that is this image. It can be observed that this first layer, or last campaign, as we say, it's the most recent one, is of finer and more homogeneous grain, being the surface smoother. Different colors were assigned to the different porosity models. Gray was selected for the total volume of interest, the VOI, with an 80% transparency. Red, or pink, was selected for all the pores, and green for the open pores. One of the abilities of the micro-CT allied to a chosen software can be shown in this short video, where it is presented the porosity distribution by the means of the open pores, as I said, in green, and all the pores existent in red, pink. The 3D analysis of the porosity parameters is depicted in the upper table on the right, while the 2D pore size distribution analysis is contemplated on the lower table. The 3D analysis established that the sample has a very high percentage of total porosity. The degradation process, if on one side mural paintings materials are very porous, on the other the degradation process occurring in its inner strata increased that percentage. SAM examination also confirms the poor condition of the mural, which is exposed to extreme humidity, lack of adequate cleaning and ventilation, with cold duties being performed only 2 days a week, and the other days they are closed. Although the painting surface, this first picture, it doesn't seem to present severe porosity, when the magnification is higher and the substrate is visible, the granular disintegration is shown, as seen in this lower picture. A video was made to show the potential of the micro-CT analyzing an object or sample, in 360 degrees. It is a little bit slower, so I'm going to fasten it for this presentation. You can see the sample in 360 degrees all around, and you can take portions of the inner structure, you can see, and freeze whenever you like, and continue to see the inner structure, and rotate the sample up and down from top to bottom and all around again. This investigation is at its beginnings. We would like also to know the content of salts and water, and to do a comparison of this data with other equipment that can estimate the porosity and content of salts in situ. The conclusions. With micro-CT, there's no need for sample preparation. It's a non-destructive technique with the possibility of reuse of the sample in other analyses. It can establish the degree of porosity, it can display the shape of the pores, and enable the study of the pores interconnectivity. It can measure the thickness of each layer and allows a 360-degree view of the sample and its interior. You can observe its internal structure, its composition, different layers, different materials, and previous restorations. The differences in grain materials, size, and opacity can be observed whenever the layers are of different materials and heterogeneous. The images can be exported in 3D or in video format. They can be displayed, the entire sample, or selected virtual cross-sections, as I showed. Ultimately, it serves to understand the condition of the painting and to devise conservation treatments. It can monitor also the changes of the application of such treatments. I thank you. These are the acknowledgements of my PhD grant research supported by the Foundation for Science and Technology. Thank you.
Okay, thank you, Alexandra, for your presentation. Does anybody have questions for Alexandra? I have one myself. You mentioned at the beginning of our presentation the problem, the issue of dark stains of the murals, but I'm not sure I completely got the connection between the pores you were talking about before, the ones you pointed out by means of CT scan, and the stains you mentioned at the beginning. Is there a connection between them? Have you spotted it thanks to the technology?
Okay, I said there is a need for a multidisciplinary approach. So to understand why these stains appear and what forms them and how we can remove them, we need to ascertain the content of salts in the walls, the porosity, the content of water, and what are the characteristics of the pigments and the granite. So the micro-CT is just one analysis. Yes, one analysis of a much larger investigation. Yes.
Okay, so I assume you are going to pick the samples and perform also chemical analysis and so on.
Yes, I was granted also. Don't know if you know what ARIS is. It's a platform, an international platform, ARIS, that we have also in Portugal, ARIS Portugal, and I was granted possibility to do in situ and on lab analysis of EDXRF, FTIR, SAM. So I did them. So I characterized the pigments. It's also to understand if the stains, the dark stains, are not, for example, lead white that is turning to black, for instance, or
yes, it could be, of course.
Some other pigments that is degrading with the light or with the humidity or so. So there are various analyses that are.
Yeah, you have plenty of work to do.
Yes. Yes.
Okay, thank you.
Thank you.
Other questions? No. Okay, thank you again.
Okay, thank you.
So this online session of the Florence Heri-Tech conference is now closing. I thank you all the presenters for their interesting contributions. From my perspective, it's been a really interesting session and provided me personally a few hints for future work in the field of cultural heritage, both from the perspective of energy and from the perspective of conservation and digitization. I thank you again for your participation, and I thank the assistants who's been participating since the beginning of the session. And I hope that to see you soon in the forthcoming Florence Heri-Tech conference that hopefully we will be able to hold in presence. Okay, and good luck to everybody.
Thank you. Thank you so much.
Thank you. Thank you, Lapo.
Thank you, Chairman.
Okay. Goodbye, everybody. Thank you again.